My talk on OAuth and OpenID Connect. The goal of this presentation is to help you understand how to implement an OAuth client, and you'll learn background information about the protocols. A little bit about myself. I am a dev at Kroger Digital, and I work on the Customer Identity and Access Management team. There's my Twitter handle in case you like to be surprised by an annual post on probably food, but you're welcome to add me or whatever, follow. And this is my cat Lulu. I love her. She's not a dev, but she does help me catch bugs. Yep. All right, so that's what you have to look forward to for the next few minutes. All right, so here's an outline of what we'll cover today. First, I'll give some context, including information about open standards and a very brief history of identity. We'll then talk about foundational concepts, including the 4 rules of OAuth 2 and a spec used to transfer information called JSON Web Tokens. We'll then walk through an interaction between an authorization server and a client. Here are my sources: RFC 6749, that's OAuth 2.0, and 6750, that's Sparrow tokens, and then the OpenID Connect handbook. I would recommend checking it out. So first, I'll provide some context for the standards and go over a brief history of identity. We'll also talk about concepts called delegated authorization, and we'll cover the difference between authorization and authentication. Before we talk about the specifics of OAuth 2 and OpenID Connect, we will cover, I'll talk a little bit about open standards in general. So open standards are industry-driven specifications that serve as a guideline for how to develop a variety of things on the internet. This is an example of that illustrates one facet of open standards, and that's that they're optional. Apple, for instance, does not typically follow standard ports, and so it makes them a lot of money selling dongles. So that just highlights one aspect of open standards is it's not mandatory. You don't have to follow it, but there are reasons to follow open standards, and they are just industry best practices, and they make things more convenient. I don't know how you feel about dongles, but I'm not a huge fan. All right, so that said, another important characteristic of open standards is that they evolve over time. So if you read an RFC and you memorize every word, 2 years later you have to accept the fact that it could be different. There could be alterations. They're constantly evolving because technology is evolving and more things are possible, and so with that, specifications change, especially in authorization and authentication. Some of the open standards we'll focus on in this talk are SAML, OAuth 2, JSON Web Tokens, and OpenID Connect. Today, we'll mostly focus on OAuth 2. Do you ever feel like tech talks too often go way back in the past just to explain a simple modern development concept? Yeah? Well, this section won't surprise you. Identity and authentication has, in a way, been a concern for all of human history. And as early as 130 BC, Romans used what's called watchwords, basically passwords, to guard areas. So they had to say a watchword in order to be allowed in. And so in a way, passwords and identity have always been a concern. But I'm going to show a little bit of constraint and focus my talk to at least computer history. So first, let's talk about the longest standing tradition in identity, the simple login. So back in the day, not necessarily my day, when computers were new and humongous and many people shared the computer, there was a need for files to be kept separate so that you would not accidentally see someone else's research. And so an MIT researcher solved the problem in 1961 with password access for each user. And so what he designed is a special keyword that you could use with the computer that would hide the text that you're typing when you're typing your password. So I imagine it's like when you are entering the password for the root user, you'll notice that you can't see your text, something similar to that. As great as this was, not even a year after passwords were introduced in computer systems, another researcher decided to be a troll, and he introduced a bug that revealed the master list of everyone's passwords. So that was the first password breach. Passwords were the first method of authenticating users and immediately revealed problems to the industry that needed to be addressed. However, for the most part, when personal computers became widespread, passwords were fine because you had to be physically at your computer in order to access it. So you would have your family computer, you'd have a password, it's probably your pet's name, and everyone could share their computer, but you don't have strangers walking into your home and using your personal computer until network, the internet. When no longer being physically there at your computer became a requirement for accessing accounts, then there was a need to protect people's accounts using the simple login form. And so the simple login form was used to keep users' accounts private. And this is probably the first login form that I used. Are there any other Neotopians out there? Yes. Have you fed your pets lately? Probably not. Yeah, I can't even keep up with the Animal Farm, or not Animal Farm, Animal Crossing, there we go. Yeah, anyway, so login forms are still an important part of the internet now. There are things that you can do to keep people's accounts safe. There are libraries that you can use to show the user how strong their password is. You can enforce password restrictions. And of course, you should never store plain text passwords. There's best practices for hashing passwords. And you can offer or even enforce MFA, and so the user you will back up the password with a different factor, such as a device. But even when these measures are taken, there are security vulnerabilities. You go to haveibeenpwned.com. You can check if your password has been pwned. The password, for instance, has been pwned almost 4 billion? Oh, very many times, and this is outdated, so it's probably even more. No matter how secure one site is, if your user is using the same password over and over, then their account can be compromised. Aside from these security factors, in the business world, there are other problems with the simple login form. Let's say ABC company has different systems for email communication, finance, and scheduling. And when an employee moves on, then an administrator will have to make sure that that person does not have access to any of those systems. And as you can imagine, there's a lot of overhead and room for human error there. And so in 2002, an organization called OASIS solved this with the SAML spec. So SAML is a great way to implement SSO in a secure and standardized way. SAML 2.0 is very prevalent in the business world today. One thing to note is SAML is XML-based, and so it's much more verbose than JSON. But again, the solution is a great way to implement SSO between between trusted systems. Another challenge emerged in the early 2000s when social media became popular. So over on the consumer side. Here's a screenshot for a social media site called Tagged. I personally have never heard of it. Has anyone? Oh yeah, okay. Are you active? No, it's probably not a thing anymore. Probably because of this screenshot. So it's hard to see, but what they're asking for is their Gmail username and their Gmail password. And the thing is, and what they want, why they're asking the user for this information is so that they can get the contact data from Google. Which makes sense, they want to be able to invite their friends. However, they're asking the user to trust this random social media site with their Gmail password, which seems overly trusting. But the thing is, there was no way to offer delegated API access at the time. In 2006, developers from Twitter, a social media site called Nolia, and Google recognized that there is no standard way to implement delegated authorization. There is no way to authorize one site to access a user's data on another site. To address this, they formed the OAuth, that's Open Authorization Discussion Group, to develop a standard. OAuth 1 was published in 2010, and 2 years later in 2012, OAuth 2, along with the bearer token spec, and they were published as RFCs in 2012. So I mentioned the term delegated authorization earlier. So now I'll explain a little bit about delegated authorization. So what they were trying to offer was for the user to be able to access their data that they owned on one site from another site. OAuth and the solution of OAuth became wildly popular when OAuth 2 was recognized as a way to access that information. It became very, very popular in social media. This, for instance, is an example of OAuth 2. The app is trying to get, can't quite see the profile information for the user from Facebook. And so the user must agree to allow that client, that application, to get that data. But in a way, OAuth became a little too popular because it was being used for things that it wasn't initially designed for. And remember, the whole point of open standards is to standardize the method of doing things. And so OAuth was designed for authorization. But notice that this button, sign in with Facebook, that is doing more than authorization. That's asking for authentication. And so this is a good time to differentiate the difference between authorization and authentication. So authorization is giving permission to someone to do something. It's like how a car key allows you to enter a car, and or a concert tickets allow you to go to a concert. Anyone with a key can get into the car. Anyone with a valid concert ticket can enter the concert. There's no ID check. Notice that there's no personal information on that concert ticket. Authentication, on the other hand, is all about verifying identity. A passport will allow you to travel to another country in some cases, and also exposes data about the person. Another example, this is before, you might remember these things from a couple years ago. So cruise cards are another example. They have the name of the person because cruises are generally non-transferable. And so there has to be an ID check there. The point of this distinction between authorization and authentication is while authorization can sometimes be granted along with authentication, like with the cruise ship card, but the reverse is not true. Authorization does not necessarily reveal anything about identity. Because OAuth 2 is a framework for authorization, something was missing to enable applications to do things like sign in with Google. Something was needed to address authentication. Which brings us to OpenID Connect. So OpenID Connect is a thin identity layer built on top of the OAuth 2 protocol. Going back to the analogy of the concert tickets and the cruise cards, they both grant access to something, but the cruise card displays the name of the person who owns the ticket. This is similar to what OpenID Connect adds to OAuth. It adds information about the user. So to summarize this section, we talked about open standards and how they are voluntary and they evolve and why they are important. We went through a brief history of the identity, including the simple login, SAML, OAuth, and OpenID Connect. We also went over delegated authorization and differentiated between authorization and authentication. Excuse me. It's a good time for a water break. All right, before we dive into the specifics of OAuth 2, let's go over some terminology, because if you study OAuth, you'll realize there is a lot of terminology. We're going to talk about the 4 roles of OAuth, authorization grant types, and a little bit about JSON Web Tokens, or JOTs, or JWTs. Who all says JWT? Who all says JOT? Who doesn't care? Yeah. I'll probably say JOT because it's shorter. So first, let's talk about the roles described by OAuth 2. First, there is the resource owner. So the resource owner is described as an entity capable of granting access to a protected resource. So when the resource owner is a person, it's called an end user. And the things that they grant access to are scopes. For instance, their profile information, their contact list, data that they own. Next is the resource server. So the resource server is the server that hosts the data. It makes decisions based off of a bearer token, whether or not the request is legitimate, and if it is, then it offers the data to the requesting application. In this example, the resource server is Google, because Google's API is the one that controls the resource owner's data. The data that the resource server has that the resource owner is granting authorization for is email, profile information, and managing contacts. The third role is the client. And just to clarify, client here isn't referring to client side. It's simply the application that is requesting authorization. So a client is an application making protected resource requests on behalf of the resource owner, or the end user, and with its authorization. In our example, the client here is LinkedIn. Once the resource owner, or the end user, grants access for the client to get data from the resource server, the end user is able to request invites to people in their Google contact list, which is so nice that you can do that, right? And finally, there's the authorization server. And I did want to note, so the authorization server is the service that is responsible for handling the authorization decisions. The authorization server is sometimes the resource server. A lot of time, if you're building an application, it's advisable to delegate that responsibility to a third-party service or library to handle authorization. But in some cases, like Facebook or Meta or whatever it's called now, they are both the resource server and the authorization server. Okay, so I'll be referring to these roles from this point forward. And if you want to make 100 grand or get some stickers, review these rules. So I've never really spoken in a room this big before, but I'm going to do my best to throw a sticker or two. It might be a bad idea. So just some warning for you. Hopefully people within my range will answer, I don't know. So let's go back to this example of OAuth 2. So who is this cute fella? Is it the resource owner, resource server, authorization server, or client? Thank you. Who is it? Yes? Oh, is it the resource owner, resource server? The client? That's a good guess. Unfortunately, wrong. Sorry. No, do you know? I'm sorry? Yes, the resource owner. So remember, the resource owner is like the end user. And I am off screen now, but I'm going to do my best. You think I can throw that far? I probably can't. All right, yeah, my range is horrible. All right, next up we have, wrong way. Yep, the resource owner, good job. All right, I think my experiment failed. I don't think I can do it in this room this big, but I have stickers up at the front at the end of the talk for whoever wants them. All right, so, yep, so next up, who is Facebook in this example? And you probably saw it. That's right, the resource server and authorization server. All right, and in the example, what is some app? Client, yes, that's the client. So the client is the application requesting the data. Nice job. Sorry, my experiment didn't work. That's okay. All right. And a bonus question, what are these items called that the resource owner is granting access to? Scopes, yep, awesome job. I think I didn't need it, so. I'll pick that up later, okay. All right, and so there's the, this is OAuth in a nutshell. Now that we understand the roles, let's talk about tokens involved in OAuth 2 and OpenID Connect. So the 3 tokens we'll cover are access token, refresh token, and ID token. So the access token is basically the whole point of OAuth. And so the access token is what the client application wants in order to get the data for the user. The refresh token is like a voucher. Access tokens, they don't last very long. They last anywhere from 15 minutes to about a day, depending on the needs of the application. And so a refresh token allows that client application to continually ask for new access tokens. And finally, we have what OpenID Connect adds to OAuth, and that is the ID token. So ID tokens are used to identify the resource owner. It's like a driver's license. ID tokens, by the way, are always going to be JSON web tokens. Access tokens are for the consumption of the resource server. They may be opaque, they may be a JSON web token, but if you're working on the client application, you really shouldn't be concerned with that because it is just an arrangement between the authorization server and the resource server. So as a client application, you just send off the access token. Don't analyze it. The ID token, on the other hand, is for the consumption of the client app. And so it is always going to be decodable. So a JSON Web Token is a compact, URL-safe means of representing claims to be transferred between two parties. There are three parts: the header, the payload, and the signature. So if you had to guess, if you took a look at the pink, red and pink part, would you say that is encoded or encrypted? Yeah, that's right, it is encoded, meaning that anyone can base64 decode the top part and get the information. And so you have to remember that you're not really obscuring the data, but the point of JSON Web Tokens is that it verifies that that they were signed by the correct person. So going through these parts, we have the header. The header contains the algorithm used to sign the token, which is very important in verifying an authentic source for the token, and the type. In this case, it's JSON Web Token. Next, we have the payload. So the payload contains the claims about the user. And so there are a list of standard OpenID Connect claims that you can use in the payload here. For instance, an important one would be the nonce. If you have I'll go more into this when we get to the different types of grant types, but if you have a single page application, you'll want to pay attention to that to prevent different attacks. And finally, we have the signature. So there are different types of algorithms used to sign JSON Web Tokens. This, for instance, is an RSA 256 signature, and so it uses a public key, and the authorization server has a private key. And so the authorization server signs the token using the private key, and it is verifiable with the public key. And so that's why you have private key, public key here. Those screenshots are taken from jot.io, by the way. So just to summarize JSON Web Tokens, there are three parts: the header, which contains the algorithm and the type. The payload are the claims about the user, so that's the information that the client application can decode and understand about the user. The signature uses the payload, the header, and this is a little bit outdated. It was a public key specified in the algorithm in order to verify the authenticity of the token. Now let's talk about authorization grants. So authorization grants are the different ways that a client can be granted access to, can be granted an access token. Here are some of the most common ones. We'll talk mostly about authorization code with PKCE. That's that PKCE, that's proof key for code exchange, and it's often pronounced PKCE. So authorization code with PKCE, device code, and client credentials. And you may wonder why I'm not talking about implicit flow. Implicit flow was the original recommendation for single-page applications, but it is no longer recommended because of advancements in technology of browser cryptography. Now it is essentially deprecated. It's no longer recommended to use implicit flow, again, because technology evolves and specs evolve, and so it's just no longer recommended. So an important consideration in determining which authorization grant to use is a characteristic called whether your app is confidential or public. So confidential and public refers to whether or not an application is able to keep a secret. So when a client application registers with an authorization server, they're issued a client ID and a client secret. Confidential clients are able to keep that client secret in a secure way. Public clients, on the other hand, have no way to do that. I'll go into more detail. So confidential clients have a back-end server and a secure way to store the client secret. Public clients, on the other hand, don't have a way of storing a secret. An example would be a single page application or a native application. There's no safe place to keep the secret because anyone can inspect the page or hack the app in order and obtain that secret. Another important thing to consider is whether a browser is involved. So you have front channel communication and back channel communication. So front channel communication, basically if there's a browser involved and API requests are viewable in the console, or back channel, that's API to API, two backend servers communicating. Those two characteristics will help you determine which authorization grant to use. In the vast majority of cases, you'll be using the authorization code with PXE. And so, like I said, recommendations are always evolving. Authorization code with PXE was originally added on top of authorization code flow for native apps, and then later on, it was used to replace implicit flow for single page applications, and now it's recommended to even use PXE with confidential clients that can keep their secret secure. And the reason for that is they have realized that there's a certain attack that is possible during the regular authorization code flow that PXE can help prevent. I won't go too deep into PXE in this talk, but I did want to mention that. Excuse me. So then there's client credentials flow. That's using the back channel. Those are two back-end systems communicating with each other, like with microservices. And device code is a really cool authorization grant, especially if you are working on a command line tool, or you're working in IoT, a Raspberry Pi or Arduino. You can use the device code flow for devices that have limited user input, like a command line tool. You can use device code flow to direct the user to a login screen and then be authenticated in your command line tool, which I think is really cool. So to summarize this section, we covered the 4 roles of OAuth 2, and I threw stickers everywhere. And we talked about the resource owner, the resource server, the client, and the authorization server. And then we talked about 3 tokens: access tokens, refresh tokens, and ID tokens. And we talked about how ID tokens are always going to be a JSON web token, and talked a little bit about that. And finally introduced some of the most popular authorization grant types. All right, so now the moment you have all been waiting for. Let's walk through the OAuth 2 and OpenID Connect flow. Okay, so remember, just as a reminder of the roles in OAuth, we have the resource owner, the authorization server, the client, and the resource owner. And so here's a diagram from the RFC that illustrates how authorization code flow works. However, I decided to make my own. Over here on the left, we have the client application. And on the right, we have the resource server is Google. The authorization server in this case is Auth0. And the resource server is also Google, because we're going to be requesting their contacts or something like that. All right, so in this example, the client application is is asking Google to authorize a request for, we're going to say the access token is a cheeseburger. So here, this is what that request looks like. So the authorized endpoint, we have the response type, the client ID, the redirect URI, the scope, and the state. Okay, and so Google recognizes that request and offers the access token, an authorization code, which can later be used to exchange for the access token, which is the actual cheeseburger. So here is the response from the authors. Here's the response that we get. We get a redirect to the client application along with a code as a query string parameter. Next, the client application will request using the authorization code for that access token. And this looks, let's see. So it requests auth0 for the access token. Sorry, I think I messed up my diagram. That's okay. And then this is what the token request, the token response looks like. Here's the ID token, the access token. And I'll go through an actual example here so it's a little bit more clear. It's not so silly. And finally, the resource, I understand now. So now that the client application has that dollar, they're able to get the user data from Google. They're able to use that dollar in exchange for the data. I just messed up my analogy, sorry about that. and finally, they use the access token as a bearer token in the authorization header. And finally, Google is able to offer that data to the client application, represented by a burger. And this is the user's data. Awesome. Next, 2 hours pass and the access token is no longer valid. So what the client application can do is use the refresh token, which again is represented by this coupon here, to get a new access token. And so we request that another access token, and we're issued another access token. And again, we can get the resource for the user. Awesome. All right, so now I will do a demo and walk through all of the requests using a sample app. One moment, let me mirror. Okay, and so what I did here is I'm using Auth0 as the authorization server, and I registered an application. So I just went to applications, and I registered a new application. And they have sample apps for you to download and use right away. And so that's what I did for this example. You just select which, I selected that I want a single page application, and then you select which framework you're using, and then you can just download a sample app. All right, so, one moment. Okay, so here's my sample app. I'm gonna start as an unauthenticated user. And so I'm going to be logging in using OpenID Connect on top of OAuth, using Google as the resource server and Auth0 as the authorization server. All right, so here's that authorize request right here. It's a bit hard to see. Let me make it a little bit bigger. Is it? Yeah, it's really small. Okay. So I'm going to scroll down to the query string parameters here. And so there are a number of things that are required for that request. We need the client ID, the redirect URI, that is where the user will be redirected after login. Scopes, again, that's what the user is requesting or is granting access to the in the request. And then we have, and we are using Pixie, and so we do send a code challenge, and we're using the that's SHA-256 to hash the challenge. All right, so I'll log in. Whoops. 1, 2, 3. Oh, I have 2 periods. There we go. All right, and so a lot of stuff happened in the network tab here, but you'll see that there is a code passed in the query string. It's immediately removed by the library I'm using, but you can see it in the network tab. You can see the code that was passed to the client application. And then the client application was able to make a token request from Auth0 here using that code. So the same code that was used, that was provided to the client application was passed back to Auth0 so to fulfill the request. And Auth0 issued an access token, an ID token, and reiterated the scopes that were requested. And again, this is a bearer token. All right, and so just to show you a little bit of what the code looks like, I did want to mention that a lot of the details of the specification, it is good to be aware of the fundamentals of it, but at the same time, you can leverage libraries, some kind of service. In this case, I'm using Auth0 to simplify it. And so, for instance, in this example, you just wrap the application component with configurations, and the library takes care of the code challenge, all of the details of refreshing the token and caching the token, and all of that is obscured away for you as the programmer. Abstracted away, that's the word I wanted. All right. All right, so just to summarize, we talked about, I gave you a brief history of identity, and then we talked about some foundational concepts of OAuth 2 and OpenID Connect, including the 4 roles of OAuth, and tokens and authorization grants. And then I walked through a transaction using OAuth and OpenID Connect. All right, thank you so much. This is a really silly slide. Any questions? No? Yep.
So when I try to implement this, the thing that usually catches me is the signature.
All right, so you said the signature is the thing that is what catches you? Mm-hmm.
Right, I was wondering if there's a library or a technique or something like that that you recommend, because it seems very, obviously very specific about how you have to compose your header and payload, or how you arrange your header and payload before you then put it through whatever secure hashing algorithm you're doing, and then basically compose it. It seems brilliant.
It is. So So what I would recommend is taking a look at a library called Jose. JSON Web Tokens. Sorry, let me not share it. I'll share it in a second when I find it. So there's a library that I really like called Jose, and it assists you in signing your token if you're working on the backend server that's actually minting tokens, or if you're working on the backend server that's verifying the tokens. So you're working on the resource server that's making sure that the token is legitimate and verifying that signature. I recommend using a library called Jose JSON Web Token. Let me find it. It's a node. Haha, found it. Yeah, so I've used this before in projects, and it is very detailed. It has a lot of flexibility, not just for JSON Web Tokens, but every area of tokens. And so I would recommend looking into this library. I know that this library is used under the hood in other authentication and authorization libraries. And so it's a good one to look into. And so just so I understand, is it the a particular, is it the specifics of like public keys, private keys, and versus a shared secret, or that you were asking?
When you compose the payload, you got to put all of your query parameters in the right order, and then you've got to make sure that it doesn't have the tiny dots in it, because the dots are used to separate the payload and the header. So those have to be encoded. You have to not encode other things, and then the whole signature encryption thing is so library dependent. It's like, well, I can't encrypt this now because I'm using this programming language and it doesn't have that library. The whole thing feels very difficult if you don't have just the right environment.
Yeah, that makes a lot of sense. Another resource I would recommend is the one that I used in the in my slides. This is jwt.io, jwt.io. And here you can troubleshoot tokens. It allows you to specify which algorithm you're using. We didn't really talk about synchronous versus asynchronous algorithms, but it allows you to select whichever algorithm you need here. And it also recommends which libraries to use that over here. And pretty much any language you're using, it will have recommended libraries for you. And as far as, I wouldn't recommend verifying and minting tokens on your own without using a library personally, because it is quite complex, and things are, like I've been saying, are constantly evolving. And so it's good to have a dedicated team that are focused on keeping up to date with different specifications. Hope that helps. All right, well, thanks again, y'all. Have a good day.